it is not correct to use a 112.5 kVA transformer with a primary voltage of 480 volts and a secondary voltage of 208/120 volts for the described application. The molding machines require a voltage of 480 volts. The proposed transformer has a primary voltage of 480 volts, which is the same as the input voltage. This means the transformer will not provide the required voltage boost for the molding machines. The substation provides a voltage of 220/127 volts. The proposed transformer has a secondary voltage of 208/120 volts, which is lower than the required voltage. This means that the transformer will not provide enough voltage to the substation to meet the demands of the factory. Therefore, you should install a dry transformer 208 to 480/277 volts delta star to correctly power the molding machines with 480 volts and feed the substation with 220/127 volts. The primary voltage of the transformer must be suitable to step up the voltage from 208 volts to 480 volts. The secondary voltage of the transformer should then provide 480/277 volts to correctly power the molding machines. The 277 volts represents the voltage from each phase to neutral in a 480 volt system. The delta star configuration is important for proper voltage transformation and grounding. A delta primary connection provides a stable voltage supply even with unbalanced loads. The star or Y secondary connection allows for a neutral point, enabling both 480 volt and 277 volt loads to be served. Firstly, ensure the kVA rating of the transformer is adequate for the load. The 112.5 kVA transformer may not be sufficient for the combined load of the four molding machines, depending on their individual power requirements. Secondly, calculate the total apparent power required by the molding machines in kVA. At a safety margin, typically 25%, to account for future load growth and inrush currents. Thirdly, select a transformer with a kVA rating that meets or exceeds the calculated value. Fourthly, verify that the transformer is designed for continuous operation at the expected load. Fifthly, confirm that the transformer's insulation class and temperature rise are suitable for the factory environment. Sixthly, check the transformer's impedance to ensure it is compatible with the existing electrical system. A higher impedance can limit fault currents but may also cause voltage drops under heavy load conditions. Seventhly, ensure the transformer complies with all applicable standards such as those from the National Electrical Manufacturers Association (NEMA) and the Institute of Electrical and Electronics Engineers (IEE). Eighthly, review local electrical codes and regulations to ensure compliance with installation requirements. Ninthly, provide appropriate overcurrent protection for both the primary and secondary sides of the transformer. This typically involves using circuit breakers or fuses sized according to the transformer's kVA rating and voltage. Tenthly, install the transformer in a well-ventilated area to prevent overheating. Dry-type transformers rely on natural air convection for cooling, so adequate airflow is essential. 11thly, perform regular inspections and maintenance on the transformer to ensure it is operating correctly. This includes checking for loose connections, signs of overheating, and any unusual noises or vibrations. 12thly, consider the impact of harmonic currents on the transformer. Molding machines, particularly those with electronic controls, can generate harmonic currents that can overload the transformer and cause overheating. If harmonic currents are a concern, consider using a K-rated transformer designed to withstand the effects of harmonics. 13thly, ensure proper grounding of the transformer to minimize the risk of electrical shock and equipment damage. The grounding system should comply with the National Electrical Code (NEC) requirements. 14thly, provide adequate space around the transformer for maintenance and inspection. This space should comply with NEC requirements for working clearances around electrical equipment. 15thly, label the transformer clearly with its voltage ratings, kVA rating, and other relevant information. This will help prevent confusion and ensure that the transformer is used correctly. 16thly, train personnel on the proper operation and maintenance of the transformer. This training should include how to identify and address potential problems. 17thly, keep a record of all inspections, maintenance, and repairs performed on the transformer. This record will help track the transformer's performance and identify any recurring issues. 18thly, consider using a transformer with a built-in monitoring system. These systems can provide real-time information on the transformer's temperature, load, and other parameters, allowing for proactive maintenance and troubleshooting. 19thly, ensure that the transformer is properly protected from physical damage. This may involve installing barriers or enclosures to prevent accidental contact. 20thly, consider the environmental impact of the transformer. Dry-type transformers are generally more environmentally friendly than oil-filled transformers, as they do not contain any hazardous materials. 21stly, specify a transformer with a high efficiency rating to minimize energy losses. This can save money on electricity bills and reduce the overall environmental impact. 22ndly, ensure the transformer is compatible with the existing power distribution system. This includes verifying that the transformer's impedance and voltage regulation are within acceptable limits. 23rdly, consider the possibility of future load growth when selecting a transformer. It is generally better to oversize the transformer slightly to accommodate future expansion. 24thly, consult with a qualified electrical engineer to ensure that the transformer is properly selected and installed. An experienced engineer can provide valuable guidance and help avoid costly mistakes. 25thly, review the transformer manufacturer's recommendations for installation, operation, and maintenance. These recommendations are based on the manufacturer's expertise and experience. 26thly, ensure that the transformer is installed in accordance with all applicable codes and regulations. This includes the National Electrical Code, NEC, and any local electrical codes. 27thly, provide adequate ventilation for the transformer to prevent overheating. This may involve installing fans or louvers to increase airflow. 28thly, protect the transformer from moisture and other environmental factors. This may involve installing a weatherproof enclosure or providing other forms of protection. 29thly, inspect the transformer regularly for signs of damage or deterioration. This includes checking for cracks, corrosion, and other signs of wear and tear. 30thly, test the transformer's insulation resistance periodically to ensure it is still within acceptable limits. This test can help identify potential insulation failures before they lead to equipment damage. 31stly, check the transformer's oil level, if applicable, to ensure it is within the recommended range. Low oil levels can lead to overheating and equipment damage. 32ndly, clean the transformer's bushings and insulators regularly to remove dirt and debris. This can help prevent flashovers and other electrical problems. 33rdly, tighten all electrical connections on the transformer periodically to ensure they are secure. Loose connections can lead to overheating and equipment damage. 34thly, lubricate the transformer's moving parts, if applicable, to ensure they are operating smoothly. This can help prevent wear and tear and extend the life of the equipment. 35thly, calibrate the transformer's protective relays periodically to ensure they are operating correctly. This can help prevent equipment damage in the event of a fault. 36thly, test the transformer's cooling system periodically to ensure it is functioning properly. This can help prevent overheating and equipment damage. 37thly, monitor the transformer's operating temperature regularly to ensure it is within acceptable limits. High temperatures can indicate a problem with the transformer or its cooling system. 38thly, analyze the transformer's oil, if applicable, periodically to check for contaminants. Contaminated oil can reduce the transformer's insulation strength and lead to equipment damage. 39thly, repair or replace any damaged or worn parts on the transformer promptly to prevent further damage. 40thly, document all maintenance and repair work performed on the transformer. This documentation can help track the transformer's performance and identify any recurring issues. Consider the transformer's ability to handle overload conditions. While transformers are designed to operate at their rated kVA, they can often handle short-term overloads. However, prolonged overloading can lead to overheating and reduced lifespan. The transformer's impedance plays a critical role in determining its ability to handle short circuits. A lower impedance allows for higher fault currents, which can trip protective devices and prevent damage to the system. However, a very low impedance can also result in excessive stress on the transformer during a fault. Consider the inrush current when the transformer is energized. The inrush current can be several times the normal operating current and can cause nuisance tripping of protective devices. The delta star connection provides a grounded neutral point on the secondary side, which is essential for many electrical systems. The grounded neutral helps to stabilize the voltage and provides a path for fault currents to flow back to the source. The 277 volt is the voltage between any phase and the neutral. The 480 volts is the voltage between any two phases. You need to make sure that your 480 volt loads are connected between phases. The 277 volt loads are connected between one phase and the neutral. You may not need to use the 277 volt at all. If all of the loads are 480 volts, then no neutral connection is needed. The transformer should be located in a clean, dry environment. The transformer should be protected from physical damage. You may need to put a fence around it to protect it from being damaged by forklifts or other equipment. The transformer should be inspected regularly for any signs of damage or wear. Any problems should be corrected immediately. The transformer should be maintained in accordance with the manufacturer's recommendations. This includes regular cleaning and lubrication. The transformer should be tested periodically to ensure that it is operating properly. This testing should be performed by a qualified electrician. The transformer should be replaced when it reaches the end of its useful life. The exact lifespan of a transformer depends on many factors, including the operating conditions and the quality of the transformer. You can get an infrared thermometer to check the temperature of the transformer under load. If it is overheating, that means that it is either overloaded, not properly ventilated, or there is some other problem. Overheating will shorten the life of the transformer. The size of the conductors on the primary and secondary sides of the transformer must be properly sized for the amount of current that they will be carrying. The National Electrical Code, NEC, has tables that show the ampacity of different sizes of conductors. The overcurrent protection devices on the primary and secondary sides of the transformer must be properly sized to protect the transformer from overloads and short circuits. The NEC has rules for sizing overcurrent protection devices for transformers. The grounding system for the transformer must be properly installed and maintained to protect people from electrical shock. The NEC has rules for grounding transformers. You will want to consult with a qualified electrician or electrical engineer to make sure that the transformer is properly selected, installed, and maintained. A qualified professional can help you to avoid costly mistakes and ensure the safety of your electrical system. Also, ensure that the terminals have been properly tightened. Vibration of the environment can cause them to loosen over time. Loose terminals can cause arcing and overheating, which can damage the transformer. Check the nameplate of the transformer for its kVA rating, voltage ratings, impedance, and other important information. Keep the area around the transformer clear of obstructions to allow for proper ventilation and access for maintenance. Consider using a transformer with a built-in temperature sensor to monitor its operating temperature. This can help you detect potential problems before they lead to equipment damage.